Hello FME friends, and welcome to this 2025.1 feature demonstration video. In this video, I will demonstrate a new transformer called the 3DSlicer. One of the most upvoted ideas on the FME community was to simplify slicing of 3D objects, and this was implemented as a new transformer in 2025.1. The 3DSlicer transformer is a way to split geometries along a three-dimensional plane. The plane can be defined by a fixed x coordinate, a fixed y coordinate, or a fixed z coordinate. For example, here is a three-dimensional solid cube displayed at a slight angle. The axes are as shown. The 3DSlicer transformer is set up to cut at a fixed value on the x-axis, midway through the solid. This is a visualization of the slice plane. The result is now two separate solid features. Notice that two attributes are added to each output feature. The sliced attribute tells us whether a feature has been sliced or not. The side attribute tells us whether this slice is from the front or the back of the slice plane. In this example, the 3DSlicer is set up to cut at a fixed value on the z-axis. It falls inside a loop containing a counter, which is used to slice the geometry horizontally at 10-meter intervals. When run, each slice exits the transformer, while the remainder of the block loops around for another slice to be cut. The different parts of the block are identified by the side attribute. In this case, back parts represent the individual slice, front parts the remainder of the block. The result is a series of horizontal slices. Rather than slicing along a defined axis, the slice plane can be defined by a point and normal. A normal is a vector that is perpendicular to the slice plane. A normal of 1, 0, 0 points along the x-axis, so its perpendicular defines a vertical slice plane. A normal of 0, 1, 0 points along the y-axis, defining a horizontal slice plane. A normal of 0, 0, 1 points along the z-axis, giving a vertical slice plane rotated 90 degrees. In this example, the point on the plane is at the center of the cube. The normal is defined as 0.5, 0.5, and 0. This gives a normal angled at 45 degrees on the y-axis. The result is two separate solid features sliced diagonally. Interestingly, the data to be sliced does not need to be a three-dimensional solid geometry. In this example, the source geometry is a simple spiral line feature. The slice plane is defined by a simple fixed x-coordinate, as shown in this visualization. The result is two features, both of which are multipart line geometries. Note that the results have been spatially separated for better visualization. Here are some final points of information about this functionality. Overall, this transformer is designed as a replacement for existing methods using the clipper and bounding box geometry. Different geometries are supported, including point clouds, 2D, and aggregates. For front and back attributes, features are in the front when they are on the positive side of the plane normal. The normal parameters define a vector, not another point on the normal. Vectors are usually a number between 0 and 1, which define an angle. I hope you found this video interesting and that you will enjoy the new functionality. Look out for other video demos for the 2025.1 release.